Assalamualaikum and good day everyone. Now we look at chapter 3, life insurance. So what is life insurance? Life insurance is a protection against financial loss that would result from the premature death of an insured. The named beneficiary receives the proceeds and is thereby safeguarded from the financial impact of the death of the insured. The death benefit is paid by a life insurer in consideration for premium payments made by the insured. So insurance company will pay benefit or financial protection to the policyholder or the insured, while the policyholder or the insured pay the premium to the insurance company. Life insurance contracts are made between life insurance company and one or more policyholders. So policyholder pays premium and insurance pays the benefit, or we call it as sum assured. There are types of benefit. For example, payable on or following the death, like term insurance or the whole life insurance. The details we will look later. And payable provided the life survive for a given term, for example, pure endowment or annuity, meaning that the life insurance company will pay benefit as long as the insured survive. First, benefit payable at the moment of death. The definitions. First, BT, or the benefit function. Benefit paid when death is at time T. X plus T is age at death. While VT, the discount function, is the present value of 1 ringgit discounted from time of payment back to the time of issue when death is all at time. VT to find the present value at t equal to 0 or time of issue. Time value of money for VT. So VT is discounted back. So 1 over 1 plus I, the power of t, or 1 plus I, the power of negative t. We also can use in terms of delta. So in life insurance, we use VT equal to E negative delta T. So this is for discount. This is for interest, which is paid more than once a year. And same as discount. So ZT is the present value function. ZT is equal to BT times VT. So BT for benefit and VT is for discount function. Therefore, the net single premium is the expected value of ZT. T is a continuous random variable represent the future lifetime of X. So GT is PDF of T, which is TPX mu X plus T. To find the expected value of present value function, we need to integrate ZT times the PDF or the GT. There are two components that we have to integrate. So ZT is BT times VT, and GT is TPX mu X plus T. Then we can also find variance for present value function. This is for VT E negative 2 delta T, and this is the NSP squared. The value from here. Second one, benefit payable at the end of the year of death. So this is for discrete case. The benefit function is write down as BK plus 1 as the benefit paid at time K plus 1. So when death happen between K and K plus 1, the benefit will be paid at K plus 1 at the end of the year of death. And for discount function, we denote it as Vk plus 1, and the present value function is Zk plus 1. So Zk plus 1 is Bk plus 1 times Vk plus 1. And same as for benefit payable at the moment of death, the NSP is the expected value of the present value function, which is includes Bk plus 1 and Vk plus 1. So K is a discrete random variable represent at the current future lifetime of X. So Gk is the probability function of K, where it is KPXQX plus K. Or we also can write down in terms of the conditional probability. If death happen between X plus K and X plus K plus 1, the benefit will be paid at the end of the year. So X plus K plus 1. So this is the formula for variance. First one, a continuous 1 ringgit N-year term insurance to X. So this is for term N-year term insurance. And for continuous, provides a payment of 1 ringgit at the moment of death of X only if X dies within the N years. So if the death happen within the N years, the insured will get 1 ringgit. However, if death happen after N years, no payment will be paid. So BT, the benefit function, will be paid if within the N years, the insured will get 1 ringgit. However, after N years, no payment will be paid. And for the discount function, Vt is equal to V the power of T E negative delta T. So Zt is equal to 1 times Vt if the death happened within the N years, and equal to 0 if the death happened after N years. So since after n years is equal to 0, so we cancel it out. So finally we get for term insurance, the NSP is equal to, so we have two components here. This is for VT and this is for the GT or the PDF of T. And the boundaries is 0 to n. This is how we write the notation. So big A with the bar is represents for the continuous case, X is the age, N is how many years for the term insurance, and 1 on the top of X for the term insurance. And we also can find the variance. So the variance is using this equation. So this is for EZT squared. The difference is only the VT. Instead of using E negative delta T, we use E negative 2 delta T. And this is the NSP squared. Now we look at law of mortality. So in this course, we will cover only two of law of mortalities. Law of mortalities is for the GT or the TPX mu x plus T. According to de Moivre's law, mu x is equal to 1 over omega minus x, where the omega is the latest age. So the survival function as x equal to xpo is 1 minus x over omega, or we can also write down as omega minus x over omega. Therefore, for s x plus t, it is equal to 1 minus x plus t over omega. Or we also can write down as omega minus x minus t over omega. Therefore, TPX, where sx plus t over sx, will get omega minus x minus t divided with omega minus x. Then the TPX mu x plus t, so this is TPX, and this is mu x plus t, since mu x is equal to 1 over omega minus x, therefore mu x plus t is equal to, this one we substitute with x plus t, and we get omega minus x minus t. Then finally we get TPX mu x plus t is 1 over omega minus x. Second law, constant force. If force of mortality mu x is constant for all x, then mu x plus t is equal to mu. So mu is constant. So for the TPX, E negative mu t, therefore TPX mu x plus t is equal to E negative mu t times mu. So we have two laws for TPX mu x plus t, de Moivre's law and constant force. So de Moivre's law, the TPX mu x plus t is equal to 1 over omega minus x. And for constant force, TPX mu x plus t is equal to E negative mu t times mu. Let's look at example 1. A 20-year term insurance with benefit of 10,000 payable at the moment of death. Calculate the NSP of this insurance if delta is 0.05 and mortality follows de Moivre's law with omega equal to 100. Let's extract the info first. So N is equal to 20, BT is equal to 10,000, the benefit, delta is equal to 0.05, X is equal to 25, so the VT is the discounted function is E negative delta T, so we have E negative 0.05T, and the mortality follows de Moivre's law, therefore TPX mu x plus t is equal to 1 over omega minus x, where the omega is equal to 100. So this is how we write the notation. 10,000 times this notation. So it represents the continuous. This is for term, this is for each, and this is for n. And the boundaries is from 0 to 20, Vt times TPX mu x plus T dt. Then we substitute the values inside. So this is omega minus x. Therefore, the answer is 0.1686. Then after we times with the benefit 10,000, we get 1,686. Let's say we want to find variance. So first, we find the EZ squared T. So the difference between the previous one is only the discount function, where it becomes E negative 2 delta T. And we get 0.1153. Then we substitute in the variance equation. And this is the NSP squared. So we just take the previous answer, 0.1686 squared. So we get 0.0869. Example 2. So same as example 1. However, this time we use force of mortality is 0.06 at all ages. So this is constant force. Since mu is constant, 0.06, so it is constant force, then we have to use Tpx mu x plus T is equal to E negative mu T times mu. Then we plug in all the values. And we take out the constant outside. And we solve the integration part. And we get 4,850.16.